Welcome back, geometry students, for another edition of Notes. These notes are titled 13-1, Notes on Areas of Parallelograms and Triangles. Let's get started. Remember, everything that I write down, you should write down. Your notes need to look exactly like my notes. If you need to pause the video, rewind as necessary. All right, a couple things that actually you should already know by now. Formulas for the area of a triangle and area of a parallelogram. Here's an example of what they would look like. Okay. The formula for the area of a triangle is 1/2 times base times height. Some people say base times height divided by 2. It's the exact same thing. I just like to put my half out there. All right, and then the formula for the area of a parallelogram is just the base times the height. Exact same thing as if it was a rectangle. All right, but notice there can be a couple things different here. The height needs to make a right angle with the base in both the parallelogram and triangle, and really all figures for that matter. The base and the height create a right angle. And that right angle might not always be inside of the triangle, okay? For example, if I have an obtuse triangle, the base is still on the bottom here, but the height needs to be from the lowest point to the highest point, and that would actually be outside the triangle in the case of an obtuse triangle, creating a right angle back here with the base. Same thing with a parallelogram. If it was slanted like this, and the base is on the bottom, or also the base could be on the top, exact same thing. The height could be outside the triangle, could be labeled outside the triangle as well. As long as it makes a right angle with the base, that could be the height. One more for a triangle. We might have a right triangle. If we have a right triangle, the base and the height make a right angle. We already have the right angle drawn on there. So the base and the height would be the legs of the right triangle. Okay? And if it was like that, or if it was like this, the base could be here, the height could be there. Same thing. All right? All those involve the same formulas. Let's get on to some examples. I have 3 examples for you. There they all are. You can copy those down or just do them one at a time with me. Okay, the first one, I've got to find the area of this triangle here. Notice it's a special triangle. There's a 60-degree angle, a 90-degree angle. That would give us a 30-degree angle up top. Here's what I always do for anything involving formulas. Area, surface area, volume, everything we get to here. I always write the formula first. By writing the formula first, I know exactly what I need. I know exactly what I need to use or need to find. Okay? I can see that the base is 48 inches. I need to know what the height is. And we can also see that this is a special right triangle, so I'm going to use my 30, 60, 90 relationship to find out what my height is. That would be x to radical 3, 2x. The side I have is 30. That's across from 30 is 48. That's what I have. So then to find the across from 60 would be 48 square root 3. Can label that on the triangle, 48 square root 3 inches. Okay, then I have a base height, find the area. Area is 1/2 times the base, 48 inches, times the height would be 48 square root 3 inches. And then I can use my calculator and solve that. I'm not going to multiply the square root of 3 in, just 1/2 times 48 will give me 1,152. And then I put that square root of 3 with it. And notice with area, I've got 2 units of measurement, inches times inches, which will give me inches squared. All right, from here on out, I'm just going to always remember that area is always squared, so I'll use it as such. All right, next example over here, I've got a triangle, and this 10 is only on the right-hand side there of that triangle there. It's 10. I've got a 43-degree angle and a 31-degree angle. I need to find the area. So if my area is given to me, represented as 1/2 base times height, I need to find the whole entire base, and I need to find the height as well. Well, 43 degrees is not going to give us a special right triangle, so we're going to have to go back and use some trigonometry with this. Trigonometry, if I put myself here at the 43-degree angle, okay, 10 is my opposite side, and my height would be my adjacent side. Thinking back to SOHCAHTOA, we're going to need to use the tangent. So the tangent of the 43 degrees would be equal to opposite over adjacent, 10 over x, we'll call it. Cross multiply, so we have x times tangent of 43 equals 10, and then divide by that tangent of 43 on both sides. So I get x equals 10 divided by tangent of 43. I can plug it in the calculator. Remember, in your calculator, check your mode first. Are you still in degree mode? So we have 10 divided by tangent of 43 And that would get us 10 point all this stuff. I'm going to round this number to the thousandths place, the third decimal place, and you'll see why later. All my intermediate values to the nearest thousandth. So 10.724 is what it would be, rounded. And that would be my height. Now I need to find the other half of my base here. Notice I've got another right triangle over there, and I got 31 degrees, so I'm going to use trigonometry again to solve for this remaining piece of the base. If I am right there, I have again my opposite side now and my adjacent side using tangent again. So if the tangent of 31 this time would be equal to 10.724 over, I'm going to call this one y, something different. Oops, sorry. There it is. Tangent of 31 equals 10.724 over y. Now, shortcut, if you haven't seen this already, when I cross multiply here, what I end up with is I'm not multiplying the tangent of the angle times the side that I already have. But I could switch the y and the tangent of 31. I'm still multiplying those two together, but if they switch places, that automatically gives me what I'm solving for y. So if the y was up here and the tangent of 31 is down here, then I have y equals the 10.724 divided by tangent of 31. So I'm just going to write that directly. Y equals 10.724 over tangent of 31. That always works when you cross multiply. You can switch those two and you're still multiplying the exact same things. Go to my calculator and I would get 17.848. All right, 17.848. Now I have everything I need to solve for the area. My base, in this case, I'm going to have to add both of these together. So area equals 1/2, and that would be 27.848. And then my height, I have 10.724. I didn't write my centimeters just because I know I'm in centimeters. Always remember to give your units of measurement if they're given. If they're not given, put just units squared. In my calculator then, I've got 154.7 centimeters squared. All right, that one involved trigonometry twice. Maybe a good review for you. It's going to come up here in a couple of units as well. Last one, I have a parallelogram. To find the area of this parallelogram, I'm going to use my base times height. All right, and for this, they only give me 5 for this piece. This would be the whole base. Or notice 12 could also be the base up there. So I have that. I just need my height. All right, and notice also I have a 45, 45, 90 triangle there. So using that special relationship, which is x, x, x square root 2. The 5 is across from a 45-degree angle. So 5, 5. The 5 square root of 2 would be this piece there. I'm not actually going to need that. All I need is that 5. Okay, so the base is 12, the height is 5. We plug it in. 12 times 5, which is 60 meters squared for the area of that parallelogram. Okay, so we're using those formulas, hopefully in a little bit different way, to review us on some of our right triangle relationships. Make sure you finish the WSQ, get those notes all, bring them to class tomorrow. Have a great rest of your day.